Hello everyone. I am Dr.E.Purushotham, Associate Professor of Physics, Department of Physics, School of Sciences and Humanities. Today, I am going to discuss about de Broglie hypothesis. So, what is de Broglie hypothesis? Before going to learn about de Broglie hypothesis and matter waves and properties of matter waves, we need to discuss about wave and particles. What is wave? What is particle? We are going to discuss about the wave and particle. What is wave? A wave is a spreading out disturbance or spreading out over the relative large region of space. It cannot be said to be locate just here and there. So you can see here what is wave? Wave is nothing but spreading out disturbance in a medium or in three-dimensional space. A wave is spreading out over a regularly large region of space, and it cannot be said to locate just here or there. That is the wave. What are the characteristics of wave? So the wave has the amplitude. For example, I am taking this is a progressive wave. The wave has amplitude. For example, this is the maximum displacement amplitude. Here also maximum displacement amplitude. So wave has the amplitude. Phase, it has the time period. For from here to here, this is the complete cycle. So, or from here to here for complete cycle, it is represented by T. For one complete cycle, the required time is called time period. Wave has the time period. Wave has the time period. Frequency, the number of oscillations per second, or frequency is equal to 1 by T. So it is a T, 1 by T, we get frequency. We get frequency. Wavelength, the distance between any two successive points. This is also wavelength. The distance between any two successive points, that is called wavelength. Wavelength. So it has the frequency, wavelength, etc. Wave is nothing but spreading out disturbance in a medium or in a space. A wave is spreading out or spread out over a regular large region of space, and it cannot be said to locate just here and there. The characteristics we can see here: amplitude, time period, frequency, wavelength, phase, intensity, etc. So it represents about wave. What about particle? So a particle or matter has every particle has a mass, and it is located at some definite point, at a particular point. So if a smallest quantity of substance of matter which occupies a certain space is called as particle. So every particle or matter has some mass, and it is located at some definite point. What are the characteristics of this particle? You can see every particle has mass. Every particle has mass. So particle is moving, it has some velocity. So these two products, mass into velocity, gives momentum. Momentum. So due to this m and v, for example, kinetic energy E is equal to half mv square. So every particle has some energy also. Energy. So particle has mass, velocity, momentum, energy, you can see. So mass, velocity, momentum, and energy. So what we are telling, so according to this matters, the light has the wave nature and particle nature. Like that matter also have the particle nature and wave nature. So we need to learn as the introduction to learn about wave nature and particle nature. What is wave? What is particle? Wave is nothing but spreading of disturbance in a medium. The characteristics of waves, amplitude, time period, frequency, and so on. So, what is particle? What is wave? Wave is a spreading out over a relative large region of space or spreading out disturbance in a medium. It cannot be locate just here and there. The disturbance can travel. A wave is nothing but spreading out disturbance in a medium due to the matter. So the characteristics of wave of or waves are so amplitude, time period, frequency, wavelength, phase, intensity, and so on and so on. So a particle or matter, a particle or matter has and it is located at some definite point, at a particular point. So if a smallest quantity of substance of matter which occupies a certain space, that is called a particle. So particle has the characteristics of so particle has mass, characteristics, mass, velocity, momentum, energy, and so on. So de Broglie concept of matter wave. Actually, the waves associated with a material particles are called as matter waves, or the matter are material particles or nature of radiation. The particles are accelerated with a certain velocity of light. The material particles are accelerated, velocity of light, they spread like a wave with a certain wavelength. That wavelength is called de Broglie wavelength. This matter is called matter wave or de Broglie wave or pilot wave. So this is the matter wave. De Broglie concept of matter wave. De Broglie concept of matter wave. So the universe is made up of light and particles. The universe is made up of radiation and matter. So de Broglie concept, we can see actually de Broglie introduced his de Broglie hypothesis in 1924. De Broglie made a suggestion that like radiation, the matter also exhibit dual nature or dual characteristics under appropriate conditions. So de Broglie concept of matter waves, you try to understand here. De Broglie concept of matter waves, the universe is made up of radiation. The light exhibit dual nature. We know very well. So de Broglie, the phenomena like what I am saying in 1924, de Broglie made up of suggestion that like radiation, matter also exhibit the dual nature. Matter also exhibit the dual nature. The universe is made up of radiation and matter. The light exhibits dual nature, wave nature, and particle nature. The light exhibits dual nature, they are wave nature and particle nature. Wave nature of light is verified by the interference, diffraction, and phenomena. Particle nature of light is verified by photoelectric effect and Compton effect. So you see here, de Broglie concept of matter waves. The universe is made up of radiation and light, radiation or light, and matter or particles. So here the wave and particle duality, or the light exhibits the dual nature duality. The phenomena like interference, diffraction, and polarization, and also and polarization. The phenomena like interference, diffraction, and polarization explained by the wave nature, explained by the wave nature of light, explained by the wave nature of light. So, wave nature, what is interference? Just two or more light waves, two or more light waves with the same frequency, same amplitude, same time period, or superimposed to each other. On the screen, we can observe dark and bright fringes on the screen. Phenomena is called interference. What I am telling here, two or more light waves, two or more light waves with the same frequency, same amplitude, and time period superimposed to each other and gives rise to dark and bright fringes on the screen. Phenomena is called interference. Like diffraction also using the waves, polarization also using the waves. So the phenomena like interference, diffraction, and polarization are explained by the wave nature. The phenomena like photoelectric effect. So particle nature. You try to understand here. You try to understand here. So this is the already I discussed in our previous class. This is the metal plate or zinc blende. The sufficient frequency light is incident on the metal plate. From the metal plate, the electrons are produced, so particles are emitted. The light is incident on the metal. The light means the number of photons are incident on the metal plate. From the metal plate, the electrons are produced, so particles are produced. It gives the particle nature. So Compton effect also, the X-rays are incident on the target. From the target to radiations of particles are emitted. So this one radiation has lower frequency and other one has the same frequency. This phenomena is called Compton effect. So the phenomena like photoelectric effect, Compton effect, etc., are explained by the particle nature. So here the wave nature and particle nature are known as dual nature of light, dual nature of radiation, light or radiation, dual nature of radiation. So, like the radiation, the matter also exhibit the dual nature. Dual nature. What I am saying here, the phenomena like interference, diffraction, and polarization are explained by the wave nature. The phenomena like photoelectric effect, Compton effect are explained by the particle nature. The wave nature and particle nature are known as dual nature of light or dual nature of radiation. Dual nature of radiation. Thus, the wave And particle nature is known as dual nature of light or radiation of light. It is important to note that the radiation cannot exhibit its particle and wave nature simultaneously. So depending on this dual nature of light or dual nature of radiation, de Broglie introduced his hypothesis in 1924. So in 1924, de Broglie made a suggestion that like radiation or light, matter also matter also exhibit dual nature or dual character under appropriate condition. So you can see here in 1924, de Broglie suggested that matter waves also exhibit dual nature like radiation or light. They are wave nature and particle nature. You can see here de Broglie hypothesis. In 1924, Louis de Broglie extended the wave-particle duality of light to the materials particles such as electrons, protons, neutrons, atoms, and molecules, etc. He reasoned out that nature exhibits a great amount of symmetry. Therefore, if a light can act as a wave sometimes and as a particle at other times, the material particles also act as waves at times. De Broglie suggested that the like radiation matter also exhibits wave particle duality. Wave particle duality. This is known as de Broglie hypothesis. So in 1924, de Broglie made a suggestion that like light radiation, matter also exhibit dual nature or dual characteristics. So in 1924, de Broglie extended the wave particle duality of light to the material particles such as electrons, protons, neutrons, and so on. So he gave a reason nature exhibits a great amount of symmetry. If a light can act as a wave sometimes and also particle at other times, the material particles also act as wave at the particular time and also other time particle and wave. So it exhibits wave nature and particle nature. The wave nature and particle nature is known as the dual nature of the particle. It is known as de Broglie hypothesis. De Broglie hypothesis. De Broglie hypothesis. In 1924, de Broglie made a few hypotheses for dual nature of matter waves. They are number one, the entire universe consists of matter and radiation. Matter is the particles, so radiation is the light. So the entire universe consists of matter and radiation. The entire universe consists of matter and radiation only. It means that if radiation energy has dual nature, matter must have also the dual nature. So the entire universe consists of matter and radiation. Consists of matter and radiation. Matter means mechanics. Radiation means light. So this is matter means mechanics. This is light. The entire universe consists of matter and radiation. The entire universe consists of mechanics and light only. It means that if radiation energy has the dual nature, matter must also have the dual nature. Second one. Nature loves symmetry. That is close parallelism between mechanics and light. The nature loves symmetry means it means the entire universe consists of mechanics and light. The entire universe consists of matter and radiation. So between the matter and radiation or mechanics and light has the close parallelism. So here matter and radiation. So this is mechanics and light. So it has the close parallelism between matter and radiation or mechanics and light. The nature loves symmetry between matter and radiation, between mechanics and light. So third point. Matter waves also exhibit dual nature like radiation. So already we discussed dual nature of light. The phenomena like interference, diffraction, polarization was explained by the wave nature of light. The phenomena like photoelectric effect and quantum effect explained by the particle nature of light. The wave nature of light and particle nature of light explained the dual nature of light. So the radiation or light has the dual nature. So de Broglie extended like the light has the dual nature and also matter also have the dual nature of the matter. So the light radiation extended to matter waves. De Broglie extended the matter waves or material particles. So matter waves or material particles also exhibit dual nature like radiation. Like radiation. Fourth point. The waves associated with material particles are called as matter waves or de Broglie matter waves. Its wavelength is called de Broglie wavelength. So, de Broglie hypothesis. The material particles are accelerated with light velocity. The material particles are accelerated with light velocity. You can see here, this is the matter wave definition I am going to give. The material particles are matter. The material particles are accelerated with light velocity. It produces some wave is known as de Broglie wave or it is also called matter wave or pilot wave. So the wave associated with material particles are called as matter wave or de Broglie matter wave. Its wavelength is called as de Broglie wavelength. De Broglie wavelength. So here, this is also we can say the hypothesis close parallelism between matter and radiation. Matter and radiation. So third one, according to Bohr, last one. According to Bohr, last point. According to Bohr, the stable states of electrons in the atom were governed by integer rules. In an atom, electron of the permitted orbits have the angular momentum. So integer multiple of h by, so this is the p is equal to h by 2 pi nh by 2 pi. Here the momentum of orbit, angular momentum or integer multiple of h by 2 pi. Hence, electrons in a stable orbits must also be supplemented with wave aspects. So de Broglie hypothesis last point, the angular momentum is equal to integral multiple of h by 2 pi. He assumed that one also. So de Broglie hypothesis. In 1924, de Broglie made a few hypotheses for dual nature of matter waves. They are number one, the entire universe consists of mechanics and light, or matter and radiation only. Second one, the nature loves symmetry. That means close parallelism between matter and radiation, or mechanics and light. Third one, matter waves also exhibits dual nature like radiation. Like radiation. The light has the wave nature and particle nature. So it is called a dual nature of light. Like that, the matter also exhibits the dual nature of matter. The waves associated with material particles are called as matter waves, or de Broglie matter waves, or pilot waves. It produces some wavelength is called de Broglie wavelength. De Broglie wavelength. Matter wave. What is the definition of matter wave? Already we discussed it. What is the matter wave? De Broglie extended the idea of dual nature of radiation to material particles. De Broglie extended the idea of dual nature of radiation to material particles. According to his hypothesis, when material particles are accelerated with velocity of light, they spread like a wave with a certain wavelength. These waves are called matter waves, or de Broglie waves. De Broglie waves are also called pilot waves. Pilot waves. Pilot waves. This is the matter wave. So you can see here, according to de Broglie's hypothesis, a moving particle is associated with a wave which is known as de Broglie wave or matter wave. De Broglie wave or matter wave. Or the perfect definition, what I am giving, the material particles are accelerated with light velocity and producing some wave. That wave is called de Broglie wave or matter wave or pilot wave. The wavelength of matter wave or de Broglie wavelength is given by lambda is equal to h by mv or h by p. Lambda is the wavelength. This is the Planck's constant. H value 6.626 or 625 into 10 to the power minus 34 joule second. So m is the mass of the particle. Mass of the particle. V is the particle is moving with certain velocity. That is V is the velocity. So P is equal to mv. The product of mass and velocity is called momentum P. Momentum. So the wavelength of matter wave or de Broglie wavelength is given by lambda is equal to h by mv, or lambda is equal to h by p. The material particles are accelerated with light velocity. These are producing some waves are called matter waves or de Broglie waves. It produces some wavelength. That wavelength is called matter wavelength or de Broglie wavelength. The de Broglie wavelength lambda is equal to h by mv, or that is equal to h by p. H by p. The material particles are accelerated with a certain velocity or light velocity and producing some wave is called de Broglie wave. With a certain wavelength is called de Broglie wavelength. Lambda is equal to h by mv, or lambda is equal to h by p. H by p. So expression for de Broglie wavelength. What is the expression? Lambda is equal to h by mv, or lambda is equal to h by p. So expression for this de Broglie wavelength. The expression of the wavelength associated with a material particles be derived on the analogy of radiation as follows. Considering, let us consider a Planck's theory of radiation. The energy of photon is given by. According to Planck's quantum theory, the light is divided into a small packet. That small packet is called quanta or photon. So the photon energy, Planck's photon energy is equal to h nu. We know frequency nu is equal to c by lambda. So substitute here hc by lambda. This is the photon energy. In general, you need to remember that is E is equal to h nu. H is the Planck's constant. Nu is the frequency. Frequency is equal to velocity by wavelength. Velocity by wavelength. So according to this, E is equal to h nu or hc by lambda. This is equation number one. According to Einstein's mass energy relation, E is equal to mc square. Let this is equation number two. So left side E and in equation 1 and 2 both are same. So we can write equation 2 is equal to equation 1. So equation 2 mc square is equal to equation 1 hc by lambda. So c square c and c gets cancelled. So lambda is equal to h by mc. If c is equal to velocity of particle, we can write lambda is equal to h by mv or h by p. This is the expression for de Broglie wavelength. Expression for de Broglie wavelength. You can see, so E is equal to h nu. According to Planck's quantum theory, E is equal to h nu or hc by lambda. This is equation number one. E is equal to h nu. Nu is equal to c by lambda. Hc by lambda because nu is equal to c by lambda. This is equation number one. So according to Einstein mass energy relation, E is equal to mc square. E is equal to mc square. So let this is equation number two. From equation one and two, we can write mc square is equal to hc by lambda c and square c and square lo 1c. So lambda is equal to h by mc. Lambda is equal to h by mc. So you can see here lambda is equal to h by mc. So equation 3, this is equation 3. Already you don't confuse. According to Planck's quantum theory, E is equal to h nu. This is photon energy. Nu is equal to c by lambda. So I am substituting in second step. This is hc by lambda. This is equation number one. According to Einstein mass energy relation, E is equal to mc square. This is E is equal to mc square. This is equation number two. Equation number two. From equation one and two, we can write mc square is equal to hc by lambda. This is mc square is equal to hc by lambda. C and square lambda is equal to h by mc. Lambda is equal to h by mc. This is equation number three. Lambda is equal to h by mc. This is equation number three. From equation three, if we consider, so equation three is the wavelength of photon. Wavelength of photon. If we consider the case of a material particle of mass m moving velocity v, then the wavelength associated with this particle is given by lambda is equal to h by mv. Here, this is v. So here, this is v. We are taking v. Then we get lambda is equal to h by mv. So lambda is equal to h by mc. So this is C. Consider here why we are taking V. If we consider the case of a material particle of mass m moving with velocity v, at the place of C we can take V. Then the wavelength associated with this particle is given by lambda is equal to h by mv. Mv is equal to p. Therefore, h by p. H by p. So, problem on de Broglie wavelength. Yes, problem. A proton is accelerated in a particle accelerator and reaches a velocity that is 1 by 20 of the speed of light. For a scientific experiment, you need to determine the de Broglie wavelength of this proton to understand its wavelength like properties. Okay, for this problem, we are taking all the values. So condition, the velocity is equal to 1 by 20 of speed of light. So velocity given by from the given data. So what they given from the given data, or simply we can write given. So velocity v is equal to 1 by 20 into light velocity c. Light velocity c. So this is equal to, yes. So simply velocity v is equal to 1 by 20 into light velocity. So v is equal to 1 by 20. What is the light velocity value? C is equal to 3 into 10 to the power 8 meter per second. So we need to write here 3 into 10 to the power 8. So we get the value V is equal to 1.5 into 10 to the power 7 meter per second. You remember that value. So mass of proton mu p is equal to electron mass. What is me? Electron mass 9.31 into 10 to the power minus 31 kg. What about proton mass? You need to remember proton mass 1.673 into 10 to the power minus 27 kg. You need to remember neutron mass 1.675 into 10 to the power minus 27 kg. You need to remember electron mass 9.31 into 10 to the power minus 31 kg. Proton mass 1.673 into 10 to the power minus 27 kg. So Mn is equal to 1.675, neutron mass 1.675 into 10 to the power minus 27 kg. What about here? Proton. So proton mass 1.673 into 10 to the power minus 27 kilograms. Kilograms. So lambda is equal to h by mv. Planck's constant value 6.625 or 626 as you like, 625 into 10 to the power minus 34 joule second. You need to remember. So calculate the de Broglie wavelength. Lambda is equal to h by mv. Substitute 6.625 into 10 to the power minus 34 all divided by mass of proton. We can write mu p also 1.673 into 10 to the power minus 27 into velocity. What is the velocity? 1.5 into 10 to the power 7 meter per second. So you can calculate lambda value 2.64 into 10 to the power minus 11 minus 14 meters. Minus 14 meters. Thus, the de Broglie wavelength of the proton is approximately 2.64 into 10 to the power minus 14 meters. So a proton is accelerating in a particle accelerator and reaches a velocity that 1 by 20 of speed of light. So we used here, this is velocity is equal to 1 by 20 into light velocity. So substituting v is equal to v is equal to same 1 by 20 same into light velocity value, substituting here 3 into 10 to the power 8 meter per second. So after calculation, we get v is equal to 1.5 into 10 to the power 7 meter per second. Meter per second. Okay, so simply you calculate this one, v is equal to 1 by 20 into 3 into 10 to the power 8. So 1 0, this is 7. So 2 1 ja, to 1.5 ja. So it is equal to 1.5 into 10 to the power 7 meter per second, right? So mass of proton 1.673 into 10 to the power minus 27 kg. So Planck's constant value, standard value 6.626 into 10 to the power minus 34 joule second. But I am taking for simplicity, H is equal to 6.625 into 10 to the power minus 34 joule second. So calculate the de Broglie wavelength. Lambda is equal to, what is the principle? H by mp into v. Because lambda is equal to h by mv. So I am taking this is p only. So substituting all the value, h value 6.625 into 10 to the power minus 34 by mp, proton mass 1.673 into 10 to the power minus 27 into velocity 1.5 into 10 to the power 7. So we get lambda is equal to 2.64 into 10 to the power minus 14. So the de Broglie wavelength of this proton, to understand its wave like properties, that wavelength is 2.64 into 10 to the power minus 14 meters. So we can see perfectly here this problem. You can see here, this is the particle accelerated velocity. So velocity v is equal to c by 20, or v is equal to 1 by 20 into c. Both are same. So substituting c value 3 into 10 to the power 8 meter per second by 20, 1.5 into 10 to the power 7 meter per second. So another type of also we can take rest mass of proton 1.673 into 10 to the power minus 27 kg, right? So mass of proton 1.673 into 10 to the power minus 27 kg. So lambda is equal to h by mv. Substituting m and v, or lambda is equal to h by p, we can calculate here separately mv 673 into 10 to the power minus 27 into 1.5 into 10 to the power 7, we get momentum. We can substitute lambda is equal to h by mv separately m and v, or we can take p. Lambda is equal to h by p. So here p value we get 2.5095 into 10 to the power minus 20 kg meter per second. So de Broglie wavelength lambda is equal to h by p. H value 6.626 into 10 to the power minus 34 joule second. In previous same problem I took 6.625 into 10 to the power minus 34. But here Also, you can see here 6.626 into 10 to the power minus 34 joule second. We can substitute here m into v in a previous, but here I am giving this p value. I am telling two types. Already I discussed the lambda is equal to h by m into v model. Now at the place of this, taking p model. So we get 2.64 into 10 to the power minus 14 meters. Thus, the de Broglie wavelength of the proton is approximately 2.64 into 10 to the power minus 14 meters. Okay, again, a proton is accelerating in a particle accelerating and reaches a velocity that is 1 by 20 of the speed of light. For a scientific experiment, you need to determine the de Broglie wavelength of this proton to understand its wave like a proton. Already I discussed, you remember electron mass 9.1 into 10 to the power minus 31 kilogram. So proton mass 1.673 into 10 to the power minus 27 kilograms here change, this is minus 27. Neutron mass, you remember, same 1.67. So at the place of 3, just to take 675. At the place of 3, just to take 3, remaining same, minus 27 kilogram. So this is the given condition. You see, from the given data, the velocity is equal to 1 by 20 of the speed of light. So v is equal to c by 20. V is equal to 3 into 10 to the power 8 by 20. We get 1.5 into 10 to the power 7 meter per second. Rest mass of the proton. So this is MP is equal to 1.673 into 10 to the power minus 27 kg. So lambda is equal to h by mv. H 6.625 into 10 to the power minus 34 m. You can substitute this 1.673 into 10 to the power minus 27, and v you can substitute separately 1.5 into 10 to the power 7, or you calculate separately p value. So substitute here. So p is equal to mv. This is the m of proton. This is the velocity. Product of these two gives the momentum. So this is lambda is equal to h by p. De Broglie wavelength lambda is equal to h by p, 6.625 into 10 to the power minus 34 by 2.5095 into 10 to the power minus 27. After calculation, we get 2.64 into 10 to the power minus 14 meters. The de Broglie wavelength of the proton is approximately 2.64 into 10 to the power minus 34. So second problem on de Broglie wavelength. Okay, next problem on de Broglie wavelength. That is lambda is equal to h by mv. In a quantum physics lab, you are analyzing an electron orbiting in the ground state of a hydrogen atom. Given that the velocity of electron in the ground state is 2.6 into 10 to the power 6 meter per second. Estimate the de Broglie wavelength of this electron. So first of all, we take, I am taking here solution. First of all, I am taking given data, given, so mass of electron 9.1 into 10 to the power minus 31 kg. And given velocity v is equal to, so the velocity of electron in the ground state, that is equal to 2.6 into 10 to the power 6 meter per second. That is the given. So calculate the wavelength. What is the principle here? Principle. Lambda is equal to h by mv. Lambda is equal to h by mv. So mass of electron 9.1 into 10 to the power minus 31, velocity v 2.6 into 10 to the power 6 meter per second. So we need Planck's constant value 6.625 into 10 to the power minus 34 joule second. Substituting here all the values, so 6.625 into 10 to the power minus 34 joule second, all divided by mass 9.1 into mass of electron 9.1 into 10 to the power minus 31 kg into mass of velocity 2.6 into 10 to the power 6 meter per second. So calculate all the values lambda, we will get 3.34 into 10 to the power minus 10 meters. So you remember 1 angstrom is equal to 10 to the power minus 10 meters or 10 to the power minus 8 centimeters. 1 nanometer is equal to 10 to the power minus 10 minus 9 meters. So here we can write 10 to the power minus 10 meters, 10 to the power minus 10 meters at the place of 10 to the power minus 10 meters, we can take 1 angstrom. Lambda is equal to 3.34 angstroms. This is the answer. So the de Broglie wavelength of this electron, lambda is equal to 3.34 angstroms. 3.34 angstroms. So try to understand this problem. Again, I am explaining from the given data, solution from the given data, what they are giving. So velocity 2.6 into 10 to the power 6 meter per second. Actually, lambda is equal to h by mv. So already given v value. So they are using electron. In a quantum physics lab, you are analyzing an electron orbiting in the ground state of a hydrogen atom. So they used the electron. So we can take mass of electron. So what is that? 9.1 into 10 to the power minus 31 kilograms. So we know m value and v value. What is the Planck's constant value, standard value? 6.626 or 625 into 10 to the power minus 34 joule second. So now calculate the wavelength. So principle lambda is equal to h by mv. Substituting all the values 6.625 into 10 to the power minus 34 whole divided by mass 9.1 into 10 to the power minus 31 into velocity 2.6 into 10 to the power 6. So after calculation, we get 3.34 into 10 to the power minus 10 meters. But 1 angstrom is equal to 10 to the power minus 10 meters. So I am taking here lambda is equal to 3.34 angstroms. So this is the de Broglie wavelength of this electron. This electron. So next, case one. Okay, de Broglie wavelength in terms of kinetic energy E. If E is the kinetic energy of the material particle, if T is having mass m, moving with velocity v, the moving velocity have the kinetic energy E is equal to half mv square. Half mv square. So multiply and divide with m, we get this one. Simply you try to understand here, the kinetic energy E is equal to half mv square. So take as it is kinetic energy half mv square. So multiplying with m this equation and dividing with m this equation. So this is m into m square of as it is m into m square. This is v square I am taking as it is whole divided by this m I am taking as it is. So E is equal to m square v square by m. So this is 2 we have, this is 2m. So as it is, we get this equation. E is equal to m square v square by 2m. M square v square by 2m. So, but P is equal to mass into velocity. So E is equal to, I am taking here mv whole square divided by 2m. So this is mv p, this is p square by 2m. This is the kinetic energy. You can see here E is equal to p square by 2m, where p is equal to mv. So p square is equal to, we can write 2m e. P is equal to whole root of 2me. Whole root of 2me. This is equation number 5. Now substituting P is equal to root 2m by e in lambda is equal to h by p. So lambda is equal to h by this p value as the substitution here, root of 2me. We get lambda is equal to h by root of 2me. This equation is known as de Broglie wavelength in terms of kinetic energy E. In terms of kinetic energy E. So again, you try to understand clearly. Just you see here. So let us consider a particle of mass m. The particle is moving with velocity v. Then the particle has the kinetic energy E. Therefore, the kinetic energy is given by half mv square. This equation is multiplying with m and dividing with m. So we get E is equal to half this m into m square as it is v square by m. So E is equal to, this is mv whole square by 2m by 2m. So E is equal to, we know very well momentum P is equal to mv. So substituting here P, this is whole square divided by 2m. So from this relation, P square is equal to 2me. This is 2m into e, 2me. P is equal to root 2me. Now substituting P is equal to root 2me in equation 5, in lambda is equal to h by p. Therefore, lambda is equal to h by p. What is p? Root of 2me. So this equation is known as de Broglie wavelength in terms of kinetic energy. In terms of kinetic energy. So simply you can understand shortcut. So this is, you see here, if E is the kinetic energy of the material particle, m is the mass of the particle, it is moving with its velocity v. So kinetic energy is given by half mv square, multiplying with m and dividing with m. So we get m square v square by 2m. So this is mv whole square, because of this is p square by 2m. P is equal to root 2m. So from equations 4 and 5, we can write, so equation lambda is equal to h by mv. This is equation number 4. From equation 4 and 5, we can write lambda is equal to h by, so this is h by p root 2mv. So this equation is known as lambda is equal to h by root of 2me is known as de Broglie wavelength in terms of kinetic energy E. So problem. So de Broglie wavelength associated with an electron problem. Calculate the de Broglie wavelength associated with an electron. De Broglie wavelength associated with an electron. So solution we need to take. So calculate the de Broglie wavelength lambda associated with an energy E. The energy is equal to this one. So given energy E is equal to 2000 electron volts. We need to change in joules. 1 electron volt is equal to 1.6 into 10 to the power minus 19 joules. We need to convert this one. So E is equal to 2000 into 1.6 into 10 to the power minus 19 joules. So calculate the wavelength. Principle. So lambda is equal to h by root 2me. So this is the equation for de Broglie wavelength associated with kinetic energy E. Substituting all the values. So h value 6.625 into 10 to the power minus 34 by root of, you need to write here h value and mass of electron value. So 6.625 into 10 to the power minus 34 joule second. Mass of electron 9.1 into 10 to the power minus 31 kilogram. This is the general. You need to remember. Okay, substituting 2 into mass 9.1 into 10 to the power minus 31. What about kinetic energy E? E value 2000 into 1.6 into 10 to the power minus 19. So this is equal to 0 point after calculation 0.0275 into 10 to the power minus 9 meters, or 1 nanometer is equal to 10 to the power minus 9 meters. So at the place of 10 to the power minus 9 meters, we can take 1 nanometer, 0.0275 nanometers. This is the problem on de Broglie wavelength. This is the problem on de Broglie wavelength. From the given data, wavelength, we need to calculate de Broglie wavelength given energy value 2000 electron volts. It is in electron volts. We need to convert into joule. 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. And also constant value, H value, Planck's constant, 6.625 into 10 to the power minus 34 joule second. So mass of electron, M is equal to 9.1 into 10 to the power minus 31 kg. So energy, 2000 electron volts. You see here, 2000 electron volts. So convert into joule. 2000 into 1.6 into 10 to the power minus 19 joule. So this is the wavelength. Calculate the wavelength. This is the principle. Lambda is equal to h by root of 2me. The de Broglie wavelength associated with kinetic energy. So h value 6.625 into 10 to the power minus 34 substitution. Root of 2 to 2. So m, mass of electron 9.1 into 10 to the power minus 31. Energy 2000 into 10 to the power 2000 into 1.6 into 10 to the power 19. So we get 0.0275 into 10 to the power minus 9 meters. So 10 to the power minus 9 meters is 1 nanometer. Answer, lambda is equal to 0.0275 nanometers. So case 2, de Broglie wavelength associated with an, okay, de Broglie wavelength associated with an electron charge of E. Associated with an electron charge E. So let us consider the case of electron of rest mass m and charge of electron E, which is accelerated by a potential difference V volts from rest to velocity V. Then its kinetic energy is given by kinetic energy you see here. So kinetic energy is equal to half mv square. So that kinetic energy is equal to potential energy EV. So potential energy is equal to EV. We know very well the potential V is equal to work done by charge Q. So V is equal to W by charge, electron charge E. So I am taking work done W is equal to E into V. The work done is treated as potential or voltage that is equal to EV. So the work done or energy at a particular time or particular place, the kinetic energy is equal to potential energy. So kinetic energy of mv square is equal to potential energy multiplying with m dividing with m. So we can write m square v square by 2m is equal to E into V. So this is mv whole square by 2m is equal to EV. So this is p square by 2m is equal to EV. P square is equal to 2m, then this is 2m into EV. P is equal to root of 2m EV. Now substituting this P value in lambda is equal to h by P. So h by root of 2m EV. This is the de Broglie wavelength associated with an electron. So this is the de Broglie wavelength associated with an electron. You clearly observe here. Let us consider the case of electron of rest mass m and charge E, which is accelerated by potential difference V. So from rest to velocity V, due to the velocity, it has some kinetic energy. Due to the velocity, it has the kinetic energy. Due to the electron charge and potential, it has the potential energy. This is the potential energy. So kinetic energy half mv square, potential energy EV. Potential energy EV. So this is multiplying with m and dividing with m, we get m square v square by 2m is equal to EV. So m square v square, this is p square. P square by 2m is equal to EV. From this relation, p square is equal to 2m EV. So p is equal to root of this value. So we can see here p is equal to root of 2m EV. Okay, from this equation 4, from this equation 4, okay, from this equation 4, where is the equation 4? Lambda is equal to h by p is the equation 4. From this equation 4 and this equation 7, lambda is equal to h by P as the substitution. Lambda is equal to h by root of 2me. So lambda is equal to h by root of 2me. This is de Broglie wavelength associated with an electron E. So substituting all the values, Planck's constant value, this is 6.625 into 10 to the power minus 34. Electron charge 1.6 into 10 to the power minus 19 coulombs. M is equal to 9.1 into 10 to the power minus 31 kg. So substituting all the values in lambda is equal to h by root of 2m ev. So substituting h value 6.625 into 10 to the power minus 34 all divided by root of 2 into 9.1 into 10 to the power minus 31 electron charge 1.6 into 10 to the power minus 19 V as this. So calculation of all these values, we get lambda is equal to, we get here, this is meters. This is 12.26 by root V angstroms. Sometimes we can take 12.27 by root V angstroms. So actually, lambda is equal to 12.2666 something. So we are taking 12.26 or 12.27 root V angstroms. So you remember lambda is equal to 12.26 root V by angstroms. Angstroms. So problem on de Broglie wavelength associated with an electron. Again, you can see all the values. Lambda is equal to h by root of 2me. Substitute here h value. At the place of h, I am substituting here h value to mass of electron. This is mass of electron into electron charge. We get 12.26 angstroms by root V. This 12.26 by root V or 12.27 root V angstroms problem you can see here. Okay, a neutron with a de Broglie wavelength of 1 angstrom is detected in a physics experiment. To understand its properties, you need to calculate its energy. How much energy does this neutron have expressed in electron volts? Okay, you see the solution. So given wavelength lambda is equal to 1 angstroms. We need to change 1 into 10 to the power minus 10 meters because 1 angstrom is equal to 10 to the power minus 10 meters. So a neutron with a de Broglie wavelength, neutron. So we need to take neutron mass Mn. So neutron mass Mn. Already we discussed electron mass 9.1 into 10 to the power minus 31 kg. You remember proton mass 1.673 into 10 to the power minus 27 kg. Neutron mass 1.675 into 10 to the power minus 27 kg. So I am taking here 1.675 into 10 to the power minus 27 kg. So calculate the de Broglie wavelength. What is the principle? Lambda is equal to h by root of 2me. 2me. Substituting 6.625 into 10 to the power minus 34 joule second by root of 2 into 1.675 into 10 to the power minus 27 E One second. Okay, this is lambda into this is 2 into 10 to the power 7. This is E. So take lambda square. This is a 6.625 into 10 to the power minus 34 all divided by this is whole square all divided by 2 into 1.675 into 10 to the power minus 27 E. You put this E here and wavelength value at the same place. Or simply, we can complete here. Simply, we are going to discuss. So, solution, given wavelength 1 angstrom, 1 into 10 to the power minus 10 meters, right? So, remaining H value you know very well, 6.625 into 10 to the power minus 34 joule second, neutron mass 1.675 into 10 to the power minus 27 kg. So formula, calculate the energy. Principal lambda is equal to h by root of 2me. Squaring both sides. Lambda square is equal to h square by 2me. So root and square gets cancelled. So from this relation, E is equal to h square by 2m lambda square. Substitute all the values 6.625 into 10 to the power minus 34 whole square all divided by 2 into mass of proton 1.675 into 10 to the power minus 27 into lambda square 10 to the power minus 10 whole square. So you get E is equal to 1.3 into 10 to the power minus 20 joules, or you can convert into electron volts also. E is equal to 1.3 into 10 to the power minus 20. This is joule. This is joule. So E is equal to 1.3 into 10 to the power minus 20 into 1 electron volt by 1.6 into 10 to the power minus 19, because 1 electron volt is equal to 1.6 into 10 to the power 1 electron volt is equal to 1.6 into 10 to the power minus 19 joules. 1 joule is equal to 1 electron volt by 1.6 into 10 to the power minus 19. So we get this is E is equal to 0.082 electron volts. Problems on de Broglie wavelength associated with an electron. Calculate the wavelength associated with an electron raised to a potential of 1600. So solution you can see here only given potential V is equal to 1600 volts. So given 1600 volts. So calculate the wavelength associated with an electron. So principal a- lambda is equal to 12.26 divided by root V. Answer we will get in angstroms. So this is equal to 12.26 by root V 1600 angstroms. So this is equal to 0.3065 angstroms. Again, you can see. So here the wavelength associated with an electron raised to the potential 1600. So solution from the given data, voltage is equal to 1600 voltage volts. Calculate the de Broglie wavelength associated with an electron. So principle lambda is equal to 12.26 by root V angstroms. So this is 12.26 by V value 1600 angstroms. So 12.26 by root 16 you can calculate. So finally lambda is equal to 0.3065 angstroms. Angstrom. Okay, what we learn in this video, I am going to summarize this one. So we learned about wave and particle. Here we can see what is wave. A wave is a nothing but spreading out disturbance. It has the characteristics amplitude, time period, frequency, and so on. So particle, if a smallest quantity of substance of matter which occupies a certain space is called a particle. The particle characteristics, mass, velocity, momentum, and so on. So de Broglie matter wave. A particle is accelerated with light velocity, produces some wave. That wave is called matter wave or de Broglie wave or pilot wave. Pilot wave. So you can see here the de Broglie concept of matter waves. The light exhibits the dual nature of light. The phenomena like interference, diffraction, and polarization are explained by the wave nature of light. And the phenomena like photoelectric effect, Compton effect are explained by the particle nature of light. Particle nature of light. The particle nature and the particle nature and wave nature is known as dual nature of light. So in this video, we observed the what is particle, what is wave, de Broglie concept, dual nature of light, and the dual nature of light in 1924, de Broglie suggested the matter waves also exhibit dual nature like radiation. So, de Broglie given his hypothesis in 1924. According to his, the De Broglie hypothesis. In 1924, De Broglie made a few hypotheses. They are the entire universe consists of matter and radiation. Second one, close parallelism between matter and radiation, or it is also known as nature laws symmetry. Matter waves also exhibits dual nature of like radiation. Matter waves also exhibit dual nature like radiation. So the waves associated with material particles are called as matter waves or de Broglie matter waves. Its wavelength is called as de Broglie wavelength. De Broglie wavelength. So matter waves you can see here. According to de Broglie's hypothesis, a moving particle associated with a wave which is known as de Broglie wavelength. So the wave of the matter wave, de Broglie wavelength is given by lambda is equal to h by mv, where h is 6.625 into 10 to the power minus 34 joule second Planck's constant. M is the mass, v is the velocity. We discussed it. So expression for de Broglie wavelength, we have calculated lambda is equal to h by mv or h by p. Lambda is equal to h by mv or h by p. So we did this problem. And also here, this problem also we completed. So de Broglie wavelength in terms of kinetic energy we studied. That is lambda is equal to h by root of 2me. So this is problem we completed and also de Broglie wavelength associated with an electron E. So V is equal, lambda is equal to 12.26 root V angstroms. This problem also we can calculate it. We can calculate it. So number one, in de Broglie hypothesis, number one, lambda is equal to h by mv or lambda is equal to h by p, we have calculated. So second one, lambda is equal to h by root of 2m e. This is E is the kinetic energy. E is the kinetic energy. So the de Broglie wavelength associated with an as in terms of kinetic energy, de Broglie wavelength in terms of kinetic energy. Number three, de Broglie wavelength lambda is equal to h by root of 2m ev. E is the electron charge. Electron charge. The de Broglie wavelength associated with an electron. So substituting all the values, we get lambda is equal to 12.26 by root V angstroms. Up to this, we have calculated in this present video. So in our next video, we will discuss wave velocity of de Broglie wavelength and matter waves. So in this, we have observed lambda is equal to h by mv. That is, what is particle, what is a wave, what is particle and wave, dual nature of light or dual nature of material particles. And de Broglie hypothesis we studied. De Broglie matter waves, de Broglie matter waves, and calculated de Broglie wavelength lambda is equal to h by mv, that is equal to lambda is equal to h by p. Second one, we calculated de Broglie wavelength lambda is equal to h by root of me, that is de Broglie wavelength in terms of kinetic energy E. Third one, de Broglie wavelength associated with an electron lambda is equal to h by root of 2 MeV, we have calculated. Or lambda is equal to 12.26 by root V angstroms. Okay, problem on de Broglie wavelength. Problem on de Broglie wavelength. So calculate the wavelength associated with an electron raised to a potential of 400 volts. You need to calculate here what is the formula we can use here. We have the formulas. Number one, lambda is equal to h by mv or h by p. And the second one, lambda is equal to h by root of 2me. This is wavelength associated with kinetic energy. Number three, lambda is equal to h by root of 2m ev. E is the electron charge. Or lambda is equal to 12.26 by root v angstroms. So here, which formula we can use here, you can see. So calculate the wavelength associated with an electron raised to a potential 400 volts. So V is equal to, from the given data, V is equal to 400 volts. So calculate, you need to calculate that one, how much value you will get. Which formula we are going to use here to try to understand. Okay, we can use fourth formula here. Fourth formula. So, principle lambda is equal to 12.26 by root V angstroms. So, lambda is equal to 12.26 by root V. V is 400 angstroms. So, substituting 400, 12.26 by what is the value you can calculate using this. So lambda is equal to 0.613 angstroms. angstroms. So clearly you try to understand, calculate the wavelength, calculate the wavelength associated with an electron. Actually, associated with an electron, lambda is equal to h by root of 2m ev. Putting h value, m value, and electron charge, we get 12.26 by root v angstroms. That's why we are using here that formula. Lambda is equal to 12.26 by root v angstroms. So substituting lambda is equal to 12.26 by root v angstroms. So we get lambda is equal to 0.613 angstroms. Angstroms. So next problem, calculate the velocity and kinetic energy of an electron wavelength 1.6 into 10 to the power minus 19. Okay, calculate velocity. So given, we can write here what they are given. So solution given. So electron of wavelength, lambda value given. Lambda is equal to 1.6 into 10 to the power minus 19 meters. So what we can calculate velocity and kinetic energy. Velocity and kinetic energy. So lambda is equal to h by mv. We can calculate v from this formula h by m lambda. H by m lambda. So what about h value and m value? So they mentioned here electron. So mass of electron 9.1 into 10 to the power minus 31 kilograms. What is that? Mass of electron. So Planck's constant H is equal to 6.625 into 10 to the power minus 34 joule second. Number one, calculate the velocity of an electron. So principle from this relation, principle, velocity v is equal to h by m lambda because lambda is equal to h by mv. Substituting all the values, 6.625 into 10 to the power minus 34 whole divided by mass of electron 9.1 into 10 to the power minus 31 into lambda 1.6 into 10 to the power minus 10. So calculate all the values, we get V is equal to 0.4386 into 10 to the power 7 meter per second. So this is the velocity of an electron, wavelength 1.6 into 10 to the power minus 10 meters. So the velocity 0.4386 into 10 to the power 7 meter per second. Meter per second. So second one, need to calculate kinetic energy. What is the principle of kinetic energy of mv square? So this is equal to half. What is the m value? Mass of electron 9.1 into 10 to the power minus 31 into v value. So 0.4386 into 10 to the power 7 whole square. So kinetic energy, I am writing here again. This is 1 by 2 into 9.1 into 10 to the power minus 31. So V 0.4386 into 10 to the power 7. This is whole square. Whole square. So substituting all the values, we get kinetic energy is equal to 0.8753 into 10 to the power minus 17 joules. So this is in joules. We can also calculate in electron volts. 1 electron volt is equal to 1.6 into 10 to the power minus 19 joules. So kinetic energy is equal to 0.8753 into 10 to the power minus 17. At the place of joule, I am taking 1 electron volt by 1.6 into 10 to the power minus 19. So kinetic energy is equal to 0.547 into 10 square electron volts. This is 10 square electron volts. So simply we can do this problem. Again, you can see here. So solution. From the given data, wavelength is equal to 1.6 into 10 to the power minus 10 meters. So number one, calculate the velocity. Calculate the velocity. So lambda is equal to h by mv. From this relation, v is equal to h by m into lambda. Substituting all the values, 6.625 into 10 to the power minus 34 Planck's constant value by mass of electron 9.1 into 10 to the power minus 31 into wavelength 1.6 into 10 to the power minus 10. So this is dash meter per second. So what is the velocity value? You can see here velocity value 0.4386 into 10 to the power 7 meter per second. So again we can calculate here number 2 kinetic energy. So calculate the kinetic energy. Kinetic energy principle you know very well of m v square. Already velocity we have calculated here. We can use this one velocity. So substituting all the values, kinetic energy is equal to half m value. You substitute here m value and v value. So kinetic energy is equal to half m 9.1 into 10 to the power minus 31. What is the velocity? Velocity 0.4386 into 10 to the power 7. So here whole square is there. So I am taking here whole square. So kinetic energy is equal to, after calculation, we get in joules 0.8753 into 10 to the power minus 17 joules. So now convert into electron volt. So 1 electron volt is equal to 1.6 into 10 to the power minus 19 joules. From this relation, 1 joule is equal to 1 electron volt by 1.6 into 10 to the power minus 19. So here I am taking 1 joule. So as it is taking here, kinetic energy is equal to 0.8753 into 10 to the power minus 17 into, at the place of 1 joule, I am taking this value 1 electron volt by 1.6 into 10 to the power minus 19. So you can calculate, finally, we get 0.547 into 10 square electron volts. So the velocity of an electron wavelength 1.6 into 10 to the power minus 19 meters velocity. 0.4386 into 10 to the power 7 meter per second, and the kinetic energy 0.547 into 10 square electron volt. Okay, now I am going to discuss wave velocity of de Broglie wave. What is wave velocity? So we are going to see here. So the wave velocity of matter wave is represented by u. U can be greater than the velocity of light, greater than c. We are going to discuss. So wave velocity of de Broglie wavelength. The wave velocity should be greater than the light velocity. So we are going to show here the wave velocity should be greater than light velocity. Light velocity. Explanation. You can see here the wave or phase velocity. Wave velocity or phase velocity. Wave velocity or phase velocity. It is also known as phase velocity. U is given by what is U? U is equal to nu lambda. Let this is equation number one. Nu is the frequency, lambda is the wavelength. So in your school studies, V is equal to n lambda. V is the velocity. Here I am taking wave velocity or phase velocity. At the place of this frequency, this is frequency. So I am taking a new wavelength as it is lambda. That is equation number one, where nu is the frequency, lambda is the wavelength. We know that the energy of material particle, the energy of material particles or particle. What is that? E is equal to h nu. This is according to Planck's quantum theory. According to Planck's, the particle energy E is equal to h nu. E is equal to h nu. So according to Einstein mass energy relation, mass energy relation, the energy E is equal to mc square. Let this is equation number three. But in equation 2 and equation 3, you can observe left side both are same. From equations 3 and 4, uh, equation 2 is equal to, we can write equation 3 because left side the energies are same. So now I am going to take here equation 2, that is h nu. This is mc square. From this relation, nu is equal to mc square by h. mc square by h. Let this is equation number 4. Now substituting equation 4 in equation 1. So we get u is equal to nu as new value. We need to substitute. U is equal to nu, that is mc square by h. But we know lambda is equal to h by mv. This h gets cancelled, gets cancelled, mm gets cancelled. So we get here u is equal to u is equal to this is c square by v. So what is the relation? U is equal to c square by v. So we can say that as the particle velocity v cannot exceed velocity of light c. So but wave velocity u is greater than velocity of light. Velocity of light. What I am saying here, as the particle velocity v cannot exceed the velocity of light c. But wave velocity u is greater than velocity of light. Wave velocity u is greater than light velocity. Light velocity. You can see here. So clearly we can observe here the wave velocity of de Broglie wave. So the wave velocity u is given by u is equal to nu lambda. This is equation number one. Consider the Planck's theory of radiation. The energy of photon is given by E is equal to h nu. But according to Einstein mass energy relation, E is equal to mc square. So according to equation 2 and 3, this is equation 2, E is equal to h nu. This is equation 3, E is equal to mc square. So from this relation, this nu is equal to mc square as it is here by divided by h. That is equation number 4. So we know that lambda is equal to h by mv. So substituting u is equal to substituting this value, substituting u is equal to nu lambda, that is equation number 1. So u is equal to nu mc square by lambda into this is mc square by h, not lambda, into lambda. So u is equal to mc square by h into lambda. What is lambda value? M by V. So Planck constant HH, this mass mm gets cancelled. Then U is equal to C square by V. C square by V. So V is speed of the material particle, which is less than the speed of the light. Speed of the okay. V is the speed of the material particle, which is less than material particle, which is less than velocity of light. Velocity of light. You can see here. This is the material particle velocity represented by V. So speed of light or light velocity c, V is less than c, but the wave velocity should be greater than light velocity depending on u is equal to c square by V. This is the wave velocity. Wave velocity. The wave velocity of the matter wave u can be greater than the velocity of light c. Velocity of light c. So we can say that u is greater than c, u is equal to c square by v. So again, simply we can understand wave velocity. Try to understand the wave velocity u, light velocity c, particle velocity v. So the particle velocity should be less than light velocity. Wave velocity should be greater than light velocity. Light velocity. So here, explanation. The wave velocity, simply try to understand explanation. I am giving only equations. So wave velocity u is equal to nu lambda. This is equation number 1. U is equal to nu lambda, where nu is the frequency, lambda is the wavelength of matter wave. Nu is the frequency of matter wave. We know that energy of material particle, according to Planck's quantum theory, E is equal to h nu. This is equation number 2. Try to understand. According to Einstein mass energy relation, E is equal to mc square. This is equation number 3. But equation 2 is equal to equation 3. So h nu is equal to mc square. From this relation, nu is equal to mc square by h. Now substituting this value in equation 1. So what is equation 1? U is equal to nu lambda. U is equal to nu as the substitution mc square by h into lambda. So U is equal to mc square by h as this lambda we know very well h by mv. So h gets cancelled, m gets cancelled. U is equal to c square by v. So depending on this equation, v is always less than light velocity, then the wave velocity should be greater than light velocity. So you can see on the screen, the wave velocity u is given by the following expression: u is equal to nu lambda, equation number 1. According to Planck's, E is equal to h nu, equation number 2. According to Einstein mass energy relation, E is equal to mc square. Therefore, this h nu energy is equal to mc square. So from this relation, this nu is equal to mc square by h. So substituting new value in equation 1 at the place of new. So u is equal to this is u is equal to new. New means this is mc square by h as this into lambda. So lambda is equal to h by mv. This h, m gets cancelled. So remaining this is c square by v, because mm gets cancelled. U is equal to c square by v, where v is the speed of the material's particle, which is less than the speed of light. Then the wave particle velocity is greater than light velocity. Next, group velocity. Properties of matter waves. Before that, wave velocity, the wave velocity of de Broglie wave. Okay, next, group velocity. What is the definition of group velocity? Yes, this is the definition. What is the definition of group velocity? The ratio between angular frequency. So group velocity, yes, group velocity definition. The group velocity is represented by V or Vg. V or Vg. So Vg is equal to d omega by dk. D omega by dk. Actually, omega is equal to 2 pi nu. It is known as angular frequency. Angular frequency. So d omega, change in angular frequency. So k is equal to 2 pi by lambda. It is called proportional constant. So the definition is the change in angular frequency to the ratio between change in d omega to dk. That is a change in angular frequency to the propagation constant. So what I am saying, group velocity definition, the ratio between angular frequency to the propagation constant is called group velocity of waves. Group velocity of waves. So definition simply, this is the change in angular frequency, change in angular frequency by change in propagation constant. The ratio between change in angular frequency to the change in propagation constant is called group velocity, or the ratio between angular frequency to the propagation constant is called group velocity. So explanation, we can observe here explanation. Considering group of waves called wave packet, group of waves that is wave packet. The wave packet travels with the velocity of matter particles. So these waves are called matter waves or pilot waves. Pilot waves. The material particles are accelerated with light velocity. With producing some wave is called material particle or matter wave. The group velocity is equal to the particle velocity. So the group velocity Vg is equal to d omega by dk. Already I wrote here d omega change in angular frequency, dk change in propagation constant, propagation constant. But the angular frequency omega is equal to 2 pi nu, that is angular frequency. Propagation constant k is equal to 2 pi by lambda, 2 pi by lambda. So this is the group velocity. The group velocity, the ratio between change in angular frequency to the change in propagation constant is called group velocity. Group velocity. So properties of matter waves. What are the properties of matter wave? What is matter wave? The material particles are accelerated with light velocity and producing some wave is called matter wave or de Broglie wave or pilot wave. Pilot wave. What are the characteristics or properties of these matter waves? These matter waves. So first one you can see here, depending on lambda is equal to h by mv. Lambda is equal to h by mv. M is small, that is lighter the particle, lighter the particle, greater will be the wavelength. So first property. So de Broglie wavelength lambda is equal to h by mv. From this equation, lambda is equal to h by mv. Lighter the particle, greater will be the wavelength. Greater will be the wavelength. So second one, what is the property? So same equation, lambda is equal to h by mv. Lesser the velocity, lighter the greater will be the, this is lighter, v is very small, so greater will be the wavelength. So first one, m is very small, lambda is very high, v is very small, lambda is very high. So first property, that is lambda is equal to h by mv, according to this formula, lighter the particle, greater will be the wavelength, greater will be the wavelength. From second, lambda is equal to h by mv, the velocity is very small, the wavelength is very high. So lesser the velocity, greater will be the wavelength. So third one, so lambda is equal to h by mv. This is the formula. If v is equal to 0, what about lambda? That is infinity. Infinity. Lambda is equal to infinity. It means that only moving particles generates wave or matter waves. So velocity v is equal to 0. The material particles are at rest. At rest. The material particles are accelerated with a certain velocity or light velocity and producing some wave. That waves are called matter waves. But at rest, the material particles are at rest. They are not producing any wave, because lambda is equal to h by mv. The velocity v is equal to 0. Lambda is equal to infinity. So velocity v is equal to 0 means at rest. Therefore, lambda is equal to According to formula also, lambda is equal to h by 0, that is infinity. So lambda is equal to infinity, it means that uh, only moving particles are producing or generating matter waves. At rest, they cannot produce any wave. Fourth point. Fourth point. According to lambda is equal to h by mv, it is independent of charge. There is no charge in this formula. Lambda is equal to h by mv. There is no charge. This fact reveals that matter waves are not electromagnetic waves, but they are new kind of waves. So electromagnetic waves and matter waves. You know very well about this matter waves definition. The material particles are accelerated with light velocity, producing some wave. That waves are called matter waves or de Broglie waves. But at rest, the charge, electron charge or any charge at rest, it produces electric field EF. If the electron is moving in a conductor, it produces electric field and also magnetic field. The conductor is accelerated, it producing changing electric field and changing magnetic field. The changing electric and magnetic field produces a wave. That wave is called electromagnetic wave. So electromagnetic wave cannot get without any charge. So the charge is moving in a conductor, the conductor is accelerated. Here, the conductor is accelerated and producing some wave. That wave is called electromagnetic wave. The material particles are accelerated with light velocity and producing some wave. That wave is called matter wave. So fourth point, you can see lambda is equal to h by mv. It is independent of charge. There is no charge in this formula. So the matter waves are not electromagnetic waves, but they are new kind of waves. But they are new kind of waves. So the velocity, fifth point, wave velocity should be greater than light velocity. Wave velocity should be greater than light velocity. So the wave nature of the matter introduces an uncertainty in the location of the position of particle, because a wave cannot be set exactly at this point or exactly at that point. Heisenberg's uncertainty principle is based on this concept. So clearly you can see properties of matter waves. You can see clearly properties of matter waves. Already we discussed. First point, clearly try to understand. Lighter is the particle, greater is the wavelength associated with. So explanation. Lambda is equal to h by mv. Depending on this formula, lighter the particle means the mass of electron or mass of the particle is very less than lambda is the higher value. So lighter the particle, the mass is very less, greater will be the wavelength associated with it. That is the first point. So second one, explanation. Same formula, lambda is equal to explanation. Lambda is equal to h by mv. Smaller the velocity, this velocity is very less, wavelength is very high. So smaller is the velocity of the particle, greater is the wavelength associated with it. Second point. Already we discussed. So third point. Third point. So according to same formula, lambda is equal to h by mv. If v is equal to 0, h by 0, that is infinity. So V is equal to 0, lambda is equal to infinity. The wave becomes independent. So, and if V is infinity, lambda is equal to 0. This shows that the matter waves are associated with moving microparticles. Microparticles. So it gives at rest, V is equal to 0. At rest, the material particles cannot produce matter waves. The third point represents if V is equal to 0, we cannot define wavelength. It means it means at rest, the material particles cannot produce any wave. The accelerating particles can produce matter waves. So fourth one, wavelength of matter wave is independent of charge. Independent of charge. So lambda is equal to h by mv. So in this formula, there is no charge. So it is independent of charge. It shows that these waves are not electromagnetic waves, but they are a new kind of waves. These are the new kind of waves. So fifth point, the velocity of matter wave depends on the velocity of material particle. It is not constant, while the velocity of electromagnetic wave is constant. Very simple. So next sixth point, the velocity of matter wave is greater than the velocity of light. So the wave velocity u should be greater than light velocity. The material particle velocity less than should be less than light velocity. That is the sixth property. Sixth property. The velocity of matter wave is greater than the velocity of light. V is less than c. The wave and particle. The wave and particle aspects of moving body can never appear together in the same experiment. So we can observe in different experiments at the same time. We cannot observe wave nature and particle nature. So the wave, you can see the wave and particle aspects moving with a body can never appear together in the same experiment. That is the seventh property. The wave nature of matter introduces an uncertainty in the position of the particle because a wave cannot be said exactly located at a particular point. Particular point. So these are the properties of matter waves. Properties of matter waves. So simply you can understand first one, lambda is equal to h by mv. So lesser the particle, greater will be the wavelength. Second one, lambda is equal to h by mv. So lesser the velocity, greater will be the wavelength. So number three, what is number three? You can see according to lambda is equal to h by mv. Lambda is equal to h by mv. If v is equal to 0, lambda is equal to h by 0. Therefore, lambda is equal to infinity. It means that at rest, at rest, the material particles cannot produce any wave or any matter wave. So lambda is equal to h by mv. It is not depending on the charge. So these are not electromagnetic waves. These are new kind of waves. Fifth one. So u should be greater than light velocity. Light velocity should be greater than light velocity. The wave nature of matter introduces an uncertainty in the location of the position of the particle because a wave cannot be set exactly at this point, exactly at that point. Heisenberg's uncertainty principle is based on this concept. Particle nature and wave nature cannot be exhibited simultaneously. You can see these are the properties of matter waves or characteristics of matter waves. Number one, lighter is the particle, greater is the wavelength associated with it. Second one, smaller is the velocity of the particle, greater is the wavelength associated with it. When velocity v is equal to 0, the lambda is equal to infinity. It means that wave becomes independent. Vice versa, v is equal to infinity, the velocity, the wavelength is also 0. It shows that the matter waves are not associated with moving microscopic particles. So at rest, the material particles cannot produce any matter wave. Fourth one. Wavelength of matter waves is independent of charge. So these are not electromagnetic waves. It shows that these waves are not electromagnetic waves, but they are new kind of waves. Fifth one. The velocity of matter wave depends on the velocity of material particle. It is not constant, while the velocity of electromagnetic wave is constant. Sixth one. The velocity of matter wave is greater than the velocity of light. The velocity of matter wave, the velocity of wave, matter wave velocity should be greater than light velocity. Material particle velocity should be less than light velocity. The wave and particle aspects of a moving body can never appear together in the same experiment. The wave nature of particle introduce an uncertainty in the position of the particle because a wave cannot be said exactly located at a particular point. So these are the properties of matter waves. Okay, thank you one and all.